Good morning, guys. Since we're having some Zoom issues, I'm going to make this video now and post it onto YouTube. Tomorrow, any questions you have, I promise you we'll go through and answer and help you in any way that we can. This is just technical stuff, and it is what it is. So this is section 1.3. We're going to talk today about finding domain and range of a function. That's our x values and our y values. Increasing and decreasing, where things are going up versus going down, and intervals of constant. And we're also going to talk about piecewise functions. So the first thing I want to look at right here is example 1. It says use the graph of the function shown to find the domain and the function values at f of -1, f of 2, and to find the range. So guys, if we're going to talk about domain, the thing we need to remember is domain is our x values. That's our x values. And we read a book from left to right. You read domain from left to right. So if I asked you what the domain of this function is, over here is the furthest left that this goes up to the x-axis. So the domain would be -1. And the furthest right that this graph goes is to +4. Now we've learned before in our previous math classes what open and closed dots mean. This dot is closed. It's a closed dot. That means this value of -1 is included. When we have a closed dot, meaning it's included, the notation around your number would be a bracket. On the right-hand side, over here, you see you have an open dot. All right, if it's an open dot, that means not included. So that means every number along this x-axis from -1 all the way up to 3.999999999 works, but not 4. So 4 is not included, and when it is not included, we use a parenthesis. So your domain for this function would be -1 to 4, where -1 is included and 4 is not. When we talk about range, all right, range is going to be our y values. All right, y values, and we read from bottom, we'll say bottom, to top. And what I mean by that is you start down here at the bottom, the furthest point to the bottom of the graph is -5. So my range would be -5 to the top. The highest point on my graph is 4. And then let's look at the dots. Both of them are solid or closed dots. That means both of those values are included. So your range for this function would be -5 up to +4. When they give you a question like f of -1, so when they say f of -1, f of x is a fancy way of saying y. So f -1 means when x is 1, what is the y value? So I'm going to look right here. When my x is 1, what is the y value? Well, that would be at +5. So your answer here, f of -1 would be 5. When they say f of 2, well, what they're asking is where x is 2 on the graph, what is the y value? So where x is 2 on the graph, I look up and my y value is at +4. So it's important that you guys understand domain and range is left to right, bottom to top, all right? X values are our domain. We read from the left-hand side, which is -infinity, to the right-hand side, which is +infinity. For range, we read from the bottom, which is -infinity, to the top, which is +infinity. And when they say f of a number, they're just saying, look on the x-axis at this number given, and what is the y value at that given x. So when we look down here in these two examples, if you notice, example 7 has arrows at the end of their graph, and example 9 has specific dots. So when we have arrows, that means this function is going to continue going forever and ever and ever and ever and ever and ever and ever. So our domain and our range is going to look a little different when we have arrows versus when we have specific starting and stopping points. So my domain, which would be my x values, my domain for this function would be -infinity to +infinity. On infinities, we never use brackets because there's no specific stopping or starting point. It's always parentheses. But as the x values continue to get smaller, my function is still growing. It's never ending. So it's going to use every single number on the number line. When I have my range, remember we read from bottom to top. So down here is negative infinity, and up here is positive infinity. So my function that has the arrows, it's continuing down, 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 down. It's going to start at negative infinity and go on until we reach right here. This is the point that this function does not go any higher, doesn't get any bigger. And then it happens to be 1. And this 1 is going to be included in the value because it's on the function line. When they ask for f of 0, remember what that means. Where the x value is 0, what is the y value going to be? And it happens to be f of 0 is 1. When I look at 0 on the x-axis, where does the function exist on the y? And that would be at 1. So in our second example here, I have specific starting and stopping points. My domain, what's the furthest left that this goes? Well, it's negative 1, negative 2, negative 3. This is negative 4. So it starts at negative 4, and it goes over here and ends at positive 4. And you notice that both of the dots are closed. They're colored in, so that means it includes those two values. When we look at the range, remember range is from bottom to top. So what is the value that the lowest that this goes? It would be 0. And then I look to see what is the highest points on this graph. So it's 1, 2, 3, positive 4. And we do have a closed dot here, and this is on the function here, so it's included in both sections. The second question asks f of 0. So when I look at 0 on the number line for x, I look up to see what the y value is, and it happens to be 4. Okay? All right, moving along to our next thing. We're going to talk about finding the domain and range of functions algebraically. This is without looking at a graph. You're going to look at it algebraically. So if I have the domain and range of this square root function, all right, you guys have to remember that there are some functions that you're going to have restrictions for. Okay, so when we're trying to find the domain and range of a function algebraically. All right, we have to understand that there's going to be some functions that don't have any restrictions, meaning you can put in any number in the world that you want to, negative, positive, 0, and you will get a value out. There are cases where you are going to have restrictions, and what I mean by that is, for instance, a square root. We can't take the square root of a negative number. We can, but it becomes an imaginary number. So when you have situations where you're going to have restrictions, you have to identify what they are. In this case, you would solve this as a linear inequality. So if I have the square root of x minus 4, it has to be greater than or equal to 0 because, like I just said, we can't take the square root of a negative number. So we would simply add 4 to both sides, and you get x has to be greater than or equal to 4. So your domain restriction would be, I can use any number that's 4 or bigger. So you would say your domain is from 4 to infinity. You can look at that and say, okay, well, how do I know that? How can I check it? Well, plug in 0. Let's just see if 0 works. If I say 0 minus 4, I'm going to take the square root of 0 minus 4. Well, I have the square root of negative 4. That's 2i. That is not a real number. So you have to solve these like they're inequalities to figure out where you would have some sort of restriction. So let's kind of look at something like this. We're only going to have restrictions when we talk about radicals, pretty much, and absolute value. So if I look at this first one, number 11, all right, number 11 says 2x squared plus 3. So think about it. Can I put in a negative number for x squared and get an answer? Absolutely. Let's try one. If I said 2 times negative 1 squared plus 3, and I get negative 1 squared is 1 times 2 plus 3, 5. Okay, that's fine. That's a possible answer. What if I plug in 0? Well, 2 times 0 squared plus 3, 0 plus 3 equals 3. Okay, that's a good answer. All right, what about a positive number like 2? So 2 times 2 squared plus 3. Well, 2 squared is 4. 4 times 2 is 8. 8 plus 3 is 11. In each case, whether I put a negative number in, a positive number in, or 0, I got a real solution. So that means here my domain for this function would be negative infinity to positive infinity. I can put in any number I want and I'll get an answer. Now range-wise, let's think about this for range. I put in a negative number and I got a positive answer. I plugged in 0 and I got a positive answer. I plugged in a positive number and I got a positive answer. So in this case, my answers aren't going to be from negative infinity all the way to positive infinity. They're going to be all positive. So think about it. If I plugged in -1, I got a 5. When I plugged in 0, I got 3. Am I going to get anything less than 3 when I plug any numbers in? No. So my range is going to go from 3 to infinity. Now, if I look at number 13, 13 is going to give me some restrictions because can you take the square root of a negative number? No, you can't. So let's set this to a linear inequality. X minus 1 has to be greater than or equal to 0. It has to be. So I'm going to add 1 to both sides, and I'm going to say x has to be greater than or equal to 1. So that means for this problem, my domain is 1, and it can be 1 because when I put 1 in here, 1 minus 1 is 0, to infinity. So think about what your answers would be for your range. Well, if I put in 1, I get 1 minus 1 is 0. Okay. If I plug in a negative number, it's not going to work. And if I plug in a positive number, it will work. So my range is going to be anything from 0 all the way up to infinity. In the case of our absolute value, okay, same thing. Think about absolute value. Anything inside absolute value is always, always, always going to be positive. So I'm not going to get any negative answers here. I can plug in a negative number. I can plug in -1. -1 plus 3 is 2, absolute value 2. I can plug in 0. 0 plus 3 is 3, absolute value. I can plug in a positive number, 1. 1 plus 3 is 4. Absolute value 4 is 4. So my domain for this function is anything. I can plug in any number in the world I want, and I'll get a real answer. That's fine. My range is what's going to be a little different. If I plug in a negative number, say I plug in -1. Well, -1 plus 3, okay, good. What about if I plug in -4? I get -4 plus 3, absolute value of -1 is 1. So if I plug in -3, well, -3 plus 3 is 0, absolute value of 0 is 0. So the lowest number that I'm going to get when I plug in anything is 0. And the highest number I get could be anything from 0 to infinity. So you guys just have to, you got to use your brain a little bit. We're going to think, we're going to look upon this and say, okay, what makes sense? We're going to take our time and solve our inequalities, and we'll move on from there. All right, next we're going to talk about intervals of increase, decrease, and constant. Something that is so super duper important that you guys need to write down and remember is you read intervals on the x-axis. The y-axis means nothing for intervals of increase, decrease, and constant. It's so important that you guys remember that, to the point where I always tell my students, just cross off anything on the y-axis so you don't get yourself confused. Increase means we go up. Decrease means we go down. Constant means it stays the same. So if I look at this example right here, I'm going to cross off everything on the y-axis. Okay? Everything on the y-axis. And I'm going to say, where is my function increasing, decreasing, and staying constant? Well, I'm going to start off with decrease. Remember, we read a graph the same way we read a book, from left to right. So from here, this point, to this point, put your pencil down on your graph, put your finger down and follow it. My graph is going down, it's decreasing. So I look on the x-axis, it's decreasing from where x is -2 to where x is 0. So we're decreasing from -2 to 0. We are going to always use parentheses when we talk about intervals of increase, decrease, and constant, because you cannot possibly increase and decrease at the exact same moment, so it's never going to include that point. So now I'm going to put my pencil here, and I'm going to follow the line over here to this point, and it's staying constant. It's not moving up or down. Again, we read intervals of increase, decrease on the x-axis. So from this point on the x-axis, which is 0, to this point on the x-axis, which is 2, my function is staying constant. Then the next piece of my function is from this point to this point, and it's going up. As I use my pencil, it's going up. So this is my increase. So from this point on the x-axis, 2, to this point on the x-axis, 4, my function is increasing. So remember, guys, we always read intervals of increase, decrease, and constant on the x-axis. So if I look here, all right, let's do this together. We're going to pretend that there's arrows on here. So again, we read a graph from left to right. So over here on the left-hand side, all right, this is over here at negative infinity, because we always talk about the x-axis. If this arrow is here, it means it's going and never, ever, ever, ever ending. Same thing here up here. So if I put my pencil here and I follow this graph, what is this function doing the entire time? It's going upwards. So all we have here is an interval of increase from negative infinity to positive infinity. There's no time that it decreases. There's no time that it stays exactly flat the same. So make sure you guys see that. All right, in this case here, we're going to put dots, specific starting and stopping points here so we can see this a little better, okay? This is -1, this is -2, this is 1, this is 2, okay, +1, +2, so you guys can see. All right, so put your pencil on the function. Remember, left to right, and we talk only about the x-axis, so we don't care about the y. From here to here, my function is doing what? It's going up. That's an increase. So we would say from this point on the x-axis, which is -2, to this point on the x-axis, which is -1, my function is increasing. So now I'm going to take my pencil, I'm going to follow to the next point, and I look, and it's doing what? It's going down. So I have an interval of decrease. On the x-axis, it's decreasing over the interval of -1 to +1. And then I have my pencil. I'm going to put it right here, and I'm going to follow my function again. And what is it doing? Oh, it's increasing again. All right, so I have another interval of increase, and we look at the x-axis. So from +1 to +2, there's an interval of increase. So again, guys, I'm going to keep saying this 100 times. You have to follow intervals of increase and decrease along the x-axis. Okay, same thing here. We're gonna evaluate this one. This is -1. This will be -2. This is 1, 2, 3, and 4. Again, intervals of increase and decrease. The only place that they matter is on the x-axis. So I start from the left-hand side, and I follow my function to the point here, and it was going up. So that's my interval of increase. And I look at the x-axis. It's increasing from -2 to 0. Now I take my pencil and I go from here to this point, and it's staying the same. It's staying constant. So that's my interval of constant. Along the x-axis, we look, it's from 0 to 2. And then I take my pencil and I draw my line from point to point, and I look on the x-axis. That was going downward. So that's our decrease. And it's going to be from 2 to 4. So hopefully that makes things a little easier for you guys to look at and kind of wrap your head around, because I know sometimes this can be really confusing. But the biggest thing to remember is that intervals of increase and decrease, you look at the x-axis only. Okay, we're going to talk about this quickly, a relative minima and maxima, okay? You're going to have sometimes graphs that have specific starting and stopping points. And then you're going to have graphs that have endpoints that are arrows. That just means they keep going on and on forever. That means you don't have, if you have a function that has arrows on the end, that it's from -infinity to +infinity, it does not have a specific ultimate highest point, lowest point. We have ebbs and flows, kind of like peaks and valleys, that we call relative minima and relative maxima. So a relative maxima would be inside your graph as it, swoops like this. It's all the peaks. It's relative to the beginning and ending of the graph. The high point would be your relative maxima, and the valleys, or the dips, would be your relative minima. So that would be like down here. Not a super crazy hard concept or anything, but just to understand what they're talking about when they mean that. Okay, let's go on here to piecewise functions. You guys have seen these before? Piecewise is not the easiest thing in the world for us to wrap our head around sometimes, but we can most definitely figure this out if you guys are paying attention to what you're doing. Piecewise is exactly what it sounds like. It's a piece of a graph, a piece of a line. what you're doing is you're looking at the line or function that they're giving you to graph, but you're only looking at a specific interval of it, not the entire thing. So let's do some of these together, and we'll see if we can kind of troubleshoot where we've had issues in the past with this. So I'm going to use two different colors. I'm going to say my top line is blue, and my bottom line is red, okay? So my blue line, I have 2x plus 3. Well, my slope in this equation is 2. And my y-intercept is 3. Okay, we all know how to graph a line. If my y-intercept is 3, I go to 3. If my slope is 2, I go up 1 over 2, down 1 over 2. It's a positive line, so it's going to slope upwards, and it looks something like this. Okay, does that make sense? You guys all know how to graph a line. We're good. The thing that's different with a piecewise is they give you these parameters. So right here, I'm going to look at the parameter that they gave me. They told me they want this line, but they only want the piece of it where the x values are greater than 0. So what I always tell my kids to do is to draw kind of your barrier and what they told you. They said 0. 0 was like the dividing line. And now you look and you say, okay, I'm sorry, it's less than. But you look and say, where are all the pieces of this line less than 0? So on my x-axis, over here, are all the numbers that are less than 0. So I don't want the right side of the line. I just want this piece that goes this way, like that. The rest of it I can erase. I don't need it. I don't need this piece of this line. I just want the piece of this line where all of the x values are less than 0. Now that says less than. It does not say less than or equal to. So I should have a nice big open dot here because it does not include 0. The second line, I could rewrite this as negative x plus 3, which would mean my slope is negative 1, and my y-intercept is at 3. So I would go up here to 3, and I would put my dot. And my slope is negative 1, so it's down 1 over 1, down 1 over 1, down 1 over 1. And it's a negative line, so it slopes downwards like this. Okay, we're just graphing a line, no big deal. Now I have to look at what the parameter is, with the guideline, with the border, however you want to say it. They want, for this part of the line, they want where x is greater than or equal to 0. So again, I'm going to draw my boundary right here. And over here are where all of the x values are greater than or equal to 0. That means I want everything on this side of the line, but I don't want anything on the other side. I only want that one piece, so that I'm going to erase this part. And then now you guys have drawn your piecewise function. So if I said to you for this graph, what is f of 3? Well, where the value of x is 3, what is the value of y? It'd be 0. If I said to you guys, what is f of negative 4? All right, where x is negative 4, what does it look like the y value is? Negative 3. So the same thing occurs, guys, for 57 and 59. It just looks a little different. I'm going to do 59 first, and then we'll talk about 57 in class tomorrow, because the square root graph, no, well, I'll do it, but if you guys have any questions, we need to talk about it. All right, I have 3 different lines I'm talking about here. I'm going to do green, blue, and red. All right, in this first line, my green line, my slope is 1, and my y-intercept is at 3. So for 59, I'm going to go to 3. My slope is 1, down 1, over 1, up 1. It's a positive line, so it's going to go something like this. Okay, graphing lines we're good at. Now we have to look at, oh, wait, I don't want the whole line. I just want a piece of it. So I want the piece of this green line where x is less than or equal to 0. So here's 0. Here's my boundary. Over here is where all the values of x are less than or equal to 0. So I want to keep everything on this piece, and I'm going to erase everything on the other side. And my dot here at 0 is closed because it's included. Okay, so now I'm going to look at the blue. Well, remember, f of x is a fancy way of saying y. So this says y equals 3. Well, think about what that line looks like, guys. We talked about that yesterday. If y equals 3, that means I just draw my line. It's horizontal. There's no slope. and it's right through 3. Now, I have to look and say, okay, well, what part of this line do I want? Well, I want only the part between 0 and 2. So that means I'm going to keep this piece. Whoops, I went a little too far. Okay, 0 and 2. So it goes from here to here. That's all I want. And I'm going to erase everything else. And then my last line, we're going to do in red. I have a slope of +2, and I have a y-intercept of -1. So I'm going to go down here to -1, and my slope is 2, so up 2 over 1, up 2 over 1, up 2 over 1. And it's going to slope this way. And I look at my parameter, and my parameter says I want where x values are greater than 2. Well, here's my boundary line. Greater than 2 is everything on this side, so that means I want to keep everything on this right-hand side, and I'm going to erase the other part of the line, which is here. So there we have our piecewise function. It's just pieces of different lines. It's really important that you guys focus on that. Very, 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 very important that you focus on that. That you can see, it's just normal graphing of functions, but the piecewise part is where you look at the parameters that they give you and you say, oh, I only want this little bit. All right, we will come back to 57 tomorrow. I know this is kind of hard to wrap your head around when you don't have the ability to ask me questions and stuff right in front of you. So go ahead and make sure you watch this video, try to do the homework, and then we'll talk about everything from 1.1, 1.2, and 1.3 tomorrow in class.